Hey, welcome to another flipped video where we're going to review an algebra skill dealing with simplifying square roots. This does not involve just putting a square root into your calculator and getting a decimal approximation. This involves simplifying a square roots in a very mathematical way. So let's get started. Basically, there are two different ways that actually can be combined together in order to simplify a square root. First is knowing your perfect squares. Like you should know what 1 squared, 2 squared, 3 squared, 4 squared, all the way up to 12 squared. You should know what those are. 1 squared, of course, is 1, 2 squared, 4, 9, 16. These are called the perfect squares. And these are numbers you should know. You should know not only that 10 squared is 100, but you should be able to reverse it and say the square root of 100 is 10. And if you know those, it's going to make your life a lot simpler. No pun intended. Simplifying square roots make your life simpler. Anyway, there's a second method that I love to teach my algebra kids about how to simplify square roots. And it is called square root prison. So let's get involved and learn how to simplify square roots using this prison type metaphor. So diving in, here's basically the deal. If you think about a square root as a prison, I mean, after all, it kind of looks like a prison. If you look down here at this square root symbol, you'll notice that it separates numbers from inside the square root away from those numbers outside the square root. And just like any prison, you want to escape. And the goal is to get numbers to escape from this prison. Now, how does a number escape from a square root prison? Well, there are two rules that govern square root prisons. First of all, in order to escape, you have to have a twin. You have to have a number that looks exactly like you do. And then the rules for trying to escape square root prison is one of those two twins. One of you will escape. The other, and this is where it takes a turn for the gruesome, the other will die in the attempt. It won't get caught. It won't get returned to prison. It disappears entirely, which I know is a grim take, but let's take a look at how this metaphor might help us simplify square roots. Okay, let's take a look at example number 1, and you'll see I have two examples for number 1, and you'll see why that is in a second. So in this first number 1, we have the number 12 in a square root prison. Now you'll notice that all these numbers have come together and they've like formed a gang of numbers. So inside square root prison, all these numbers have grouped up into a gang. And the first thing we want to do is we want to see what it is we're dealing with. So we're going to separate the numbers out that make up 12. And that process is called factoring. So think of two numbers that multiply to give you 12. And I'm going to start out by factoring 12 into 2 times 6. Now notice this 2 is in square root prison, so is the 6. Nobody has escaped. We're just separating out the numbers. Now, 2 is a complete separate number, but 6, that can be broken down even further. So I'm going to keep the 2, and I'm going to break the 6 down into 2 times 3. So what do we have? We have radical 12, the square root of 12, completely broken down into these three numbers. And now we look for twins. Are there any numbers here that are twins? Identical, look the exact in all ways. Sure, these two are. So what's the rule? One of these twins gets out. The other one doesn't make it. Completely disappears. Now what about this 3? Can this 3 escape from square root prison? No, doesn't have a twin. So what do we have? We're left with 2 times radical 3. This 2 escaped. This 3 couldn't escape. Now, if you think about why this worked out, let's come over here to this example for number 1. If we would have chosen 2 different factors, I'm not going to say better, I'm going to say 2 more efficient factors, we may have chosen instead of 2 and 6, 4 and 3. And the reason why this is nice is we know what the square root of 4 is. The square root of 4 is a perfect square. The square root of 4 is 2. So this becomes 2 times radical 3. The whole idea of having twins is twins means that a number has been multiplied by itself. That is what forms a perfect square. And since a square root undoes that, we basically are going back to the original number. Now let's practice some more together. So coming down here, let's practice number 2, the square root of 48. And so the first thing you do is you say, well, let's get these numbers cleaned up. I have 48 inside a square root prison, so I'm going to break it apart. And I chose to break it up into 6 times 8. Again, nobody's escaping. We're just factoring. Now, 6, even though it's a smaller number than 48, it can be broken down even further. So can 8. So I broke 6 down into 2 times 3. And I broke 8 down into 2 times 4. And I'm almost done. I think one of these numbers can be broken down even further, and it's the 4. So my final breakdown here, this 2 is going to stay. This radical 3 is going to stay. This radical 2 is going to stay. But this 4 can be broken down. Now we're going to look for some twins. So let's see what we have. Oh, I see a pair of 2's right here. So 1 2 gets out. The other 2 doesn't make it. Oh, I see another pair of 2's here and here. So one of these 2's gets out. The other one, not going to make it. And this 3 doesn't have a twin. So let's see. We got 2 2's to come out and a 3 that's still trapped. And of course, let's clean up the outside here. 2 times 2, 4 radical 3. Now, I want to look at that problem, but this time I want to look at it with a little bit of thought. Sure, we could factor 48 into 6 times 8. But if you go back and you think about your perfect squares, 1, 4, 9, 16, 25, there's a really big perfect square that goes into 48. And if I would have given some thought, and if I know my multiplication facts really well, 48 is 16 times 3. And if you're able to give this a little bit of thought before you dive in, you can save yourself a lot of work, because we all know the square root of 16 is 4. So let's keep looking at some examples together and see how we do. Here's the square root of 72. Now this would be a good point for you to pause the video and try this yourself. Break 72 apart. Break it down as far as you can. Try to let those twins escape. Some of them make it out, some of them not so lucky, and see what you end up with. Hey, welcome back. Hopefully you broke this down. Most kids, I think, choose 8 times 9. And then they realize 8 can be broken down further, so can 9. And when you break 8 down into 4 times 2, that 4 can be broken down even further. So you really want to stay neat. You really want to keep track of all your numbers. And we end up looking for twins. Let's see, there's a pair of 2's here. One twin gets out, the other one not so lucky. Oh, there's a pair of 3's here. 1 3 gets out, the other one not so lucky. And we end up with this 2 trapped. A 2 got out, a 3 got out, a 2 stayed behind, and then we clean this up. Now, some of you who put some thought into this beforehand and who are really good with your perfect squares may have realized that 72 is really 2 times 36. And you should know the square root of 36 is 6. So some of you may have arrived at the answer of 6 radical 2 much faster than others. Let's take a look at 2 more examples. This time I want to include some variables. So don't freak out because there are variables here. Let's see how they escape. So we're going to do the same thing we've always done. We're going to break this apart. Now this time I'm going to break that 52 up into 2 times 26. X to the 5th means there are 5 x's. Y to the 4th means there are 4 y's. I think I can break this up even further. 26 breaks down into 2 times 13. And there are my 5 x's and my 4 y's. So now when I hunt out my twins, I see, well, we have a pair of 2's. So 1, 2 gets out. The other one, not so lucky. There's nobody to break out this 13. And when we look at the x's, we have a pair of x's. One x gets out, the other one, nope. We have another pair of x's. One of those x's gets out, the other one, nope. And in terms of the y's, we have a pair of y's. One escapes, not the other. And another pair of y's. One escapes, the other one not so lucky. So when I look at who's escaped, we had a 2 get out, we had 2 x's get out, and we had 2 y's get out. And when I look at who's left behind in square root prison, we have a 13 and an x. And that's why we get a 2, x squared, because 2 x's got out, y squared, because 2 y's got out, and trapped behind is a 13x. Now, I think most of you should be able to logic your way through the variables without writing out 5 x's and 4 y's. You ought to be able to pair up those variables and think about how many twins you have, how many are going to make it out, and then how many of those variables don't have a twin to break out. Think about all that as you try this very last problem, number 5. Again, pause the video, factor away, and see if you can arrive at the answer I'll show you shortly. Hey, welcome back. I hope you paused the video, and this is the answer you should end up getting. 6x squared, y to the 4th, z to the 4th, and left behind under our square root is a 5xz. Well, there's today's lesson. You have some homework problems to do. So take your time, do those homework. Again, just like factoring, the more you practice, the better and faster and more efficient you get. Have a good day.